Quantitative literacy is all around us. Whether we read a news blog or shop for an item, quantitative information is implemented everywhere. Quantitative analysis helps make informed decisions. How we present data changes how it appeals to the audience. For example, let's look at the Pop Chips advertisement. Within this ad, Pop Chips have been compared to fried chips and kettle-style chips to show that Pop Chips are a healthier choice. Fat, carbs, protein, and fiber count have been compared between the three categories, and the difference is used to help customers make an informed decision. In simple words, quantitative analysis is a way of measuring or evaluating items through the examination of mathematical values of variables. Quantitative analysis helps define problems, see alternative points of view, speculate about causes and effects, and create evidence-based writings. Quantitative analysis provides individuals the skill to analyze situations. It gives them the ability to understand and create writing supported by quantitative evidence. By recognizing how writers frame numbers to support the story they tell, you will understand that other stories are also possible. Ethical use of numbers means that one uses reputable sources and does not invent or intentionally distort numbers for his or her own purposes. Do not ignore alternative points of view. When analyzing data, ask yourself, what do the numbers show? How can the numerical information be used to establish the context or significance of the topic? How can the numbers help describe the topic more precisely? What is the unit of measurement? What was the numeric information compared to? What evidence is there that the measurement procedures are reliable, valid, and otherwise sound for the purpose of the study? What might have influenced the findings? To understand quantitative data and make logical conclusions, you must first familiarize yourself with the basic numeric terms. When calculating maximum and minimum, the maximum number is the highest possible, for instance, 100 on a quiz. The minimum is the lowest possible, for instance, 0 on a quiz. If a student made a 95, that's the highest score, but not the maximum score, 100. Range is the difference between the highest and the lowest observations. Subtract the lowest from the highest, the range between 100 and 90 is 10. Mode is the most frequent observation. Here in this example, with all these numbers in the parentheses, the mode is 5. Mean is the average of scores. The total of all scores added and then divided by the number of scores. Here, in this example, the mean is 4. Median cuts the observation in half. It is a score that occurs in the middle. Here, in this example, with the numbers in the parentheses, the median is 3. If you have an even number of scores, add the middle 2 and divide by 2. Here in this example, 4 plus 4 equals 8. 8 divided by 2 equals 4. So the median is 4. Frequency is how often an observation occurs. For instance, how many times did the boy hit the ball? Let's say he hit the ball 20 times out of 100 tries. Relative frequency is expressed in percent. In this case, the frequency is 20 and the relative frequency is 20%. Sometimes we know a score or value has increased or decreased, but by how much? By calculating the percent of change, we can determine how much change occurred. Percent change is all about comparing old to new values. Comparing old values help calculate how much a value has changed. As Math is Fun website explains, the formula to calculate the percent of change increase is to subtract the new value from the old value and divide it by the old value, then multiply that number by 100. For example, if there were 200 customers yesterday and 240 today, to calculate the percentage increase, you will subtract 200 from 240, divide it by 200, and then multiply by 100. Here we have a 20% increase. But if there were 240 customers yesterday and 200 today, to calculate the percent decrease, you will subtract 240 from 200. Divide it by 240 and then multiply it by 100. The results show a 16.6% decrease. The mode used to interpret the data can alter the rhetorical effect of a statistic.